Hello guys, welcome again to Gym Athletics with Martin. Today we are going to be talking about number system. Now here you agree with me that numbers are very important aspect of our lives. We use numbers to do various things. Now take for example, we use numbers to assign values to things like money, like age, and the likes. We also use numbers to count items. So numbers are very important aspect of our life. So I can say, for example, I have 10 exercise books. So you see 10 there indicating numbers. So it gives me an idea of how many books I have. So you see that numbers are very important aspect of our life. So today we are going to look at what are those systems of writing these numbers. There are various systems of writing these numbers. So that's why we come up with the topic number system. Now I would like you to know that these numbers are written in bases. When we mean bases, they could be in base 2, base 3, base 4, 5, and downwards, even though yes we have more, but for now these are the few bases that we are going to be looking at today. So I would like you to come along with me while we deal with numbers. So take for example now, I have a number like this, 5,823. So this number 5,823. Now from the look of things, this number is written in base 10. Now why do I say these numbers are written in base 10? So let us look at the values, that's the place values of each of the digits that make up this number. Now you will see that the digit 5, this is 5, okay, let me start from here. This is the units, the tens, the hundred, and then the thousand. So I have 5 here, this is 5. What does this simply mean? It means 5,000. So to split this, I'm going to have 5,000 plus, what do I have here? This is 800. I'm going to write it this way, 800. Plus, what do I have here? That's 2 tens, which is similar to 20. 2 tens, 20, and then 3, and that's 3 units. So I'm going to write 3 this way. So you can see that this number can be expanded this way. Now I can also expand it further or write it in another way, such as this. I could say this is same as saying 5 times 1,000 plus, I'm going to have 8 times 100. I could put this in brackets to make it easier. Plus, this is 2 times 10. And then plus, this will be 3 times. Now, I'm going to write this, this will be 3 times 1, right? So I have 5 times 1,000 is same as 5,000. 8 times 100, same as 800. 2 times 10, same as 20. And then 3 times 1, same as 3. I can still break this further again to have, or express it further to have, this can also be written as 5 times 10 raised to power 3. And that's because 10 raised to power 3 is similar to 1,000. 10 times 10 times 10. 10 times 10, 100 times 10, 1,000. I can again write this way, 8 times 10 raised to power 2. So you can see 10 raised to power 2 is 100. Here also 2 times 10 raised to power 1. Yes, 10 raised to power 1 is the same as 10. And then here we have 3 times 10 raised to power 0. Now it will interest you to know that any number aside 0 raised to power 0 is similar to 1. So when I say 10 raised to power 0 is same as 1. Even if I say 6 raised to power 0 is 1. But you bear in mind that 0 raised to power 0 is not equal to 1. So it works for all other numbers assigned 0. So that's why I'm having 10 raised to power 0 here, which is similar to 1. Now you will see that here I have 5,823. And I expanded it this way to have 5 times 10 raised to power 3 plus 8 times 10 raised to power 2 plus 2 times 10 raised to power 1 plus 3 times 10 raised to power 0. So if I'm to simplify this to bring it all together, I'm going to have 5,823. Now you notice that here we have 10, 10, 10, 10. And that is to say that this number is in base 10. So when we say number basis, that's just exactly what we mean. So I can say that this number is written in base 10, but are there other bases in which we can write numbers? Yes, of course. And that's why we have here, numbers can be written in base 2, they can be written in base 3, 4, 5, 6, 7, 8, 9, and so on. So now, these are the digits that are involved in writing numbers according to their bases. So when we have numbers in base 2, basically the digits you find there are zeros and 1. If they are in base 3, the digits you find there are 0, 1, 2. If they are in base 4, you find 0, 1, 2, 3. So these are the digits that are actually used. Take for example, we have something like this. This is 5823. That's 5,823. Now, I would like you to know that this number is in base 10. And that's why I could be able to express it this way in these bases. Does that mean that if I have number in base 2, that means I'm going to express them in 2 powers, in powers of 2, or rather in 2 raised to powers, several powers? Yes. That is what will exactly happen. So if I have, take for example, I have number like this. Let's say I have 101. Now you can see, let me say this is in base 2. So how can I be able to express this? Can I express this in base 2? Yes, I can express it in base 2. That is to say, I'm going to have 1 times 2 in this way, raised to power 3, that's no, raised to power 2, and then plus 0 times 2 raised to power 1, plus 1 times 2 raised to power 0. Now, I can be able to express it this way, and that is because it is in base 2. So, for numbers that are in base 10, how do we know them? Usually, we don't write the subscript here for them. But anyway, we have some authors or some books that actually represent them. So take for example, I can have 58, and you will notice some books will write it this way, 58 base 10, or you will see them write it this way. So if it is written this way, that tells us that by default it is in base 10. If it is written this way, it still indicates base 10. But for other bases, we must indicate. For other bases, we must indicate that this is the base in which we are writing these numbers. So I believe you understand what I mean by bases. So looking at this now, this number is in base 10. Now the next thing there is that can we be able to change numbers from one base to the other? Right, maybe numbers in base 4, change them to base 5, or numbers in base 10, change them to any other base that we have. So that's what I'm going to be looking at further. That is converting numbers in base 10 to other bases. Numbers in base 10 to other bases. So let's take for example now, we have, for example, let's have numbers like this. Let's have numbers like 823. Okay, maybe this will be a little bit large, so let's just make it a little bit small, like let's say 149. And I want to change this to, this is in base 10, and I want to change this 149 to base 3. Let's say 149 to base 3. I'm going to have also the second example I'm going to take. Let's have 225 to base 7 and 3. I think this should be enough. So let's have this now. We have the first one now to change numbers from base 10. Don't forget I said whenever we have written the number this way without indicating the base, that tells us that by default it is in base 10. But as I told you earlier on, some books actually indicate by writing 10. But if we are dealing with other bases aside base 10, that means we must indicate what base that number is in, what base that number is in. Otherwise, it will be assumed to be base 10. So, of course, this is base 10, this is also base 10, and we want to change this to base 3, and likewise this also to base 3. So, to do that, now we are going to divide. So, let's have 149, and we want to change it to base 3. So, that means we are going to divide in the base in which we are changing the base 10 number to. We are going to divide in that. So I'm going to divide with 3. Now 3 goes into 14. I'm going to have 4 remaining 2 here. 3 goes into 29. I'm going to have, that should be 3, that should be 9. Remainder 2. So that means it goes into 27. 3 times 9, is 27. Now I'm going to write the remainder. Now this is done whenever we are dealing with number basis. So we write the remainder just by the side here, and I will continue dividing with 3. So I have 3 goes into 4, that's 1 with the 1 here, 3 goes into 19, I'm going to have 6 remaining 1, and then 3 again, 3 goes into 16, I will have 5 remaining 1, and then 3 goes into 5, that is 1, it goes 1 times, remaining 2, and then 3 goes into 1, that is, of course, we can't bring out 3 out of 1, so that's, we don't have any 3 that we can bring out of 1, remainder 1 itself, and then I'm going to take it upward this way. That's to say, I'm going to arrange the digits starting from the base here. So 149 is written as 1, 2, 1, 1, and 2. And I have to indicate the base, that is base 3. I have to indicate the base, because if I don't, it will be assumed to be base 10. So you can see that 149 is written as 12112 base 3. Now I would like you to also know that we don't call this 12,112. That would be wrong. That's because that name is assigned to base 10 numbers. So we don't call this 12,112. Rather, because it's in base 3, so rather we call that 12112 base 3. So that is to say that, what does this simply mean? Someone can say 149, that is base 10, and another person will say 12112 base 3. So you see, they all mean the same thing. So you can see that I've been able to convert number in base 10 to number in base 3. Now that works similarly for this also. I can do that for this. That is to say, I'm going to divide further with 7. But then I would like to go back to what I said earlier on again, which is this is 149 and this is in base 3. Now you will notice that the digits involved in this base 3, just here we have 1 and 2. Those are the digits that are used here. You will never find digit 3 among base 3 numbers. And that's why I say numbers that are written in base 3, these are the digits that are involved, 0, 1, 2. So let's take a look at the other example. We are going to divide again 2 to 5. We are going to divide by 7 because we are changing to base 7. Now if you are changing base 10, that's base 10 numbers. If you are changing base 10 numbers to other bases, what do? You are going to divide. So what do I mean by that? 10 to other bases, you divide. So this is an acronym I came up with. 10 to other bases, you divide. So I'm going to divide with the base I'm changing to. So 7 goes into 22. I'm going to have 3 remaining 1. 7 goes into 15. That will be 2 remainder 1. I'm done with the division. So that will be 2 remainder 1. And again, I'll continue with 7. 7 goes into 32. That it goes into 28. That's 4 times. Remaining, and I have 2, and that will be 4. And then again, that 7 goes into 32 4 times. Into 2, that's 28. Then remaining 4. I'm going to have that here. And then 7 goes into 4. I cannot be able to break out a whole 7 from 4. So that means that 0 remaining 4. So at the end of the day, I'm going to take it from the base down upward. So I have 225, which is similar to 4, 4, 1. And I'm not going to leave it this way, but I have to indicate the base. That is base 7. So you can see that 225 is changed to 441 base 7. As I said, again, you don't call this 441, rather you call it 441 base 7. So you would see that the digits that are actually involved here, 4 and 1. So anytime you are dealing with base 7 numbers, these are the possible digits that you can find. These are the possible digits that you can find. So this is changing from numbers in base 10 to numbers in other bases. Now, how about if I'm going to change from other bases to base 10? That's what we are going to be looking at further again. So I'm going to create some space here to have converting from other bases to base 10. So I'm going to have converting numbers in other bases in other bases to base 10. To base 10 numbers. So let's have, for example, and to convert this. So let me have something like this. Let's say I have 1, 1, 0, 1. This is in base 2. I'm to change that to base 10. And let's pick another base, like let's say I have 2, 4, 0, 5. So the possible base that this can be, it can be base 6, can be base 7, 8, 9, or 10. So I think I would love to take base 6, rather. I would love to take base 6 now. So if I'm going to change this to base 10 numbers, now how can I be able to do that? I have 1, 1, 0, 1, base 2. Base 2. Now, what does that simply mean? It means the bases in which I'm going to represent these numbers are going to be base 2. So I would start by writing it's just a way of indicating what the powers will be. This will have power 0. The base 2 here we have power 1. This we have power 2. This we have power 3. So you can see it's just like I assign numbers starting from 0 here, from behind, 0, 1, 2, 3. So, when am I going to have this 1 here times 2 power 3? That's it. Times 2 power 3, the base here. Plus, I have this 1 times 2 power 2. Plus, I have this here, 0 times 2 power 1, and then plus I have 1 times 2 power 0. So now I will go further to simplify this. So what I'm going to have will be 1 times 2 raised to power 3 is 8, plus 1 times 2 raised to power 2 is 4, plus 0 times 2, that's 2 raised to power 1 is still 2. And then plus, I have 1 times, remember I said 2 raised to power 0 is going to be 1. Any number aside 0 raised to power 0 always collapses to 1. So I have 1 times 8, which is 8, plus 1 times 4, that's 4, 0 times 2, that's 0, and then 1 times 1, that's 1. So when I add this up together, it gives me 13. So that is to say 1101 base 2 is same to 13, similar to 13. So you can see that successfully I have converted this base 2 number to base 13. I mean to 13 in base 10. Now, do I have an acronym for that? Yes, I do. So if I'm changing from other base to base 10, I will be multiplying. So multiplying, that is, I'll multiply from other base to base 10. So initially I talked about base 10 to other bases. I divide. Why I multiply when I'm changing other base to base 10. So I'm going to also look at the other example again that I gave, which is going to be in base 6. So this is in base 6. So just like what I did earlier on, I'm going to assign numbers to the power starting from here. Here will be power 0, 1, 2, and 3. So what does this mean? It means 2 times 6 raised to power 3 plus I'm going to have 4 times 6 raised to power 2 and then plus 0 times 6 raised to power 1 and finally plus 5 times 6 raised to power 0. So don't forget, before you go on, you have to indicate powers to the base. You have to indicate powers to the base, starting from 0 and from the end here. So here I'm going to have, that's 2 times 6 raised to power 3, that's 6 times 6, which is 36. 36 times 6, I guess it should be 216. So let's see that. So 6 times 6 is 36, 6 with 3. 6 times 3 is 18. Of course, that's 216. Plus, we have 4 times 36. Plus, I have 0 times 6. And then plus, I have 5 times 6 raised to power 0, that's 1. Don't forget that. 6 raised to power 0 is 1. So I'm going to multiply this. 2 times 16, that gives me 2 times 216. That gives me 432 plus 4 times 16. So I have 36 times 4. That should give me 144, yes. And then I have 0 times 6, that's 0. Plus 5 times 1, that gives me 5. So I'm going to add that up together. I have 432 plus 144 and plus 5. So that gives me 11 with the 1 here. I have 8 and then I have 5. So this is 581. Remember I told you that in some books or some teachers will actually indicate here by writing 10. But it's not that necessary. Now, if we have 10 here, fine, it's okay. If we don't have 10 here, it is assumed to be base 10. But if you're dealing with other bases other than 10, base 10, you have to indicate the base in which you are writing this number. So, I believe that with these few examples that I've used to be able to explain how to convert numbers in base 10 to other bases and also numbers in other bases back to base 10. So don't forget to subscribe to my YouTube channel so that anytime I upload videos like this, you are going to get a notification on them. Thank you very much. Maths is easy.